Hello, Algebra 1 class. These are our notes for section 212, writing and graphing systems of linear equations. So a system of equations is a set of two or more equations with the same variables. A solution to the system of equations is, so this is where it gets a little bit tricky. So what we really need is we need numbers for all of those variables that work in the equations at the same time. So let's see, how do we figure that out? How do we write that? A list of numbers, and we're going to say x, y, z, dot, 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 because there could be more than two that make all the equations true at the same time. So the way that we're going to see this with a graph is it's going to be our point of intersection. Because remember, the graph is going to have any point on the graph is really a solution to an equation, and we want it to be a solution of both. So it's going to be a point of intersection of the graphs. So that's the really important thing today. This is the really, we're going to emphasize that. Emphasize it, underline it. This is a really important thing for what we're doing today. All right, so looking at our word problem now. So a costume designer needs some silver and gold thread for the costumes for a school play. She needs a total of 240 yards. At a store that sells thread by the yard, silver thread costs 4 cents a yard and gold thread costs 10 cents a yard. The designer has $15 to spend on thread. So let's make sure we understand the problem. So this is a costume designer. She needs lots of yards of thread. It sounds like gold costs more than silver, right? And that makes sense to me. So the silver is only 4 cents a yard. Gold is 10 cents a yard. She needs a lot of it total, 240 yards. It seems like an awful lot of thread. And she's got $15 to spend. How many yards of each color should she get if she's buying exactly what is needed? So exactly what is needed means she needs 240 yards and is spending all of her budget. So let's remember that all of her budget is $15. So we're going to go ahead and write a system of equations to describe this. So we're going to have two equations. We're going to have an equation with our yards, and we're going to have an equation with our money, because there's two different things going on. So let's go ahead and assign some letters for variables here. So our x is going to be the variable where we're talking about our amount of silver thread. And the y we're going to use for our gold, because we don't know exactly how much of each we need. But we know that together it has to be 240 yards, and we know that the money we spend on silver and gold has to be $15. And we're going to write an equation for each of those things. So for our yards equation, well, if x is the yards of silver and y is the yards of gold, and together we need 240, that means x plus y is going to equal 240. And then if we are looking at a money equation, well, we know that we have 4 cents to spend on, 4 cents each yard of silver. So if we have 4 cents and we're trying to figure out how much money total, 4 cents per yard, so 0.04 times x yards of silver is how we'd figure that out. And then let's see, for the other one, we need to take and we need to multiply the 10 cents per yard times our y, and altogether that needs to be $15. So that's going to be our equation. So now we've got to go ahead and graph these. And this is a little bit tricky. Whenever we do word problems, the numbers are not small and neat and easy to work with. So fortunately, I've already figured out a scale. The scale, we should be, every square should be 20, but I'm going to label 40, I'm going to label 80. I don't want to label every single 20 because I just don't have space. So I'm counting by 40s and labeling like every other square here. So it's like 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240. And I'll do the same thing on the X. Remember, Y is our gold. Gold. Y, X is our silver thread. And it's yards of gold thread, yards of silver thread. So let's go ahead and label here 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240. So you can see it's really difficult to label the numbers any closer than that, and that's why I couldn't label every single line. So if we're graphing and I'm looking at x plus y equals 240, and I'm trying to find an x-intercept, then I am letting my y equal 0. So that means I have x plus 0 equals 240, which means my x is 240 when my y is 0. And that makes sense because if I need 240 yards total and I'm buying no gold, then that means all 240 yards has to be silver. So that's the ordered pair 240, comma 0. So let's go ahead and fix that, 240, comma 0. So all gold, or all silver, no gold. So that's going to be this point right here. And to kind of reverse that, if I want my y-intercept, that means I would let my x equal 0, which means 0 plus y equals 240, which means y equals 240, which means if I buy 0 silver, then all 240 yards is gold. So that's 0, comma 240. So that's this point right here. And then I would need to go ahead and connect these. All right, to graph the second one, I know that my x-intercept is just going to be off this page, so that's not going to be a way to graph that one, just using the scale I have. So that's one of those, like, you kind of got to trust me because I've done some work on this already. And so I'm going to get all of this stuff out of the way, and then we're going to take that second equation and we're going to work on solving it for y. So we have a y equals mx plus b. So let me go ahead and get my pen back here, and then I accidentally erased some numbers I didn't mean to erase. So we'll go ahead and fix that. And then let's write down our second equation. So it was 4 cents x, so 0.04x, plus 10 cents y, 0.10y, equals 15, and we're solving for y. That means I want to subtract the x part on both sides, which means 0.10y equals negative 0.04x. I forgot to put that x with it on both sides, and then plus 15. So remember, I always put my x part and then my number part, and then I want to go through and divide by 0.10. And it is okay if you have to grab a calculator for this part. We don't expect you to do kind of awkward numbers like this in your head, but dividing by a tenth is not too bad. What it's really doing is it's making all of our decimals bigger because we're dividing by a tenth of something, which means we're taking each whole and we're coming up with 10, right? If I take a 1 and I divide that by 10, I get 10. So it's like increasing everything by a magnitude of 10. So this will be negative 0.4x plus 150. And I would probably want to write that negative 0.4 as a fraction. That's negative 4/10 x. And I might even want to call it negative 2/5 x. And I know you're thinking, well, how can I count down and over 2? The scale is so weird. I can't tell where down 2 and over 5 is. But because each square is worth the same in the x and the y direction, we can still just count down 2 over 5 and it's going to work. So it doesn't matter When I'm counting down 2 over 5, I'm really counting down 40 and over 100, but that's still 4/10, so it's fine. Because our scales are the same in both directions, we can still just count down 2 squares over 5 squares. It will be proportional. So for my second graph, I need to start at, I think I'm going to use green here, I need to start at 150. So 150 is right here. And it's down 2 squares over 5, so 1, 2, and then over 1, 2, 3, 4, 5 is right here. And then down 2 over 1, 2, 3, 4, 5. Down 2, 1, 2, 3, 4. So it's kind of off the page there, huh? Which I knew was going to happen because I kind of had already practiced this. And my point of intersection is right in here. So my point of intersection turns out to be at, well, if this is 140, this is 160, it's going to be 150 for x. And it's kind of in the middle of this square between 80 and 100, so 90 for y. So I think it's really difficult to tell an exact answer with this. And I did go ahead and check this with a graphing calculator before I shared it with you. And again, I can just promise that when I have you do something on a test or a quiz, the numbers are going to be a lot easier. This is a really difficult graph to be sure that you're getting the right answer on. And that's why graphing is not always our best method. When I look at this point, it's hard for me to really tell for sure. It kind of looks like it could be 151 over 90, right? Or 151 comma 90 or 153 comma 90. We're just not exactly sure. And that's why graphing is not really our best method for something like this. But it does give us a nice picture. And like I said, I do know that it's the right answer because I've checked it. So if our solution is 150 comma 90, that means we should buy 150 yards of silver and 90 yards of gold thread. And a way that I could check this is I could actually substitute it into both equations and show that it works. So 150 plus 90 does in fact equal 240 yards. So it works in the first equation. And then if I want to check it in the second, what I would do is I would take 0.04 times 150. So that's the one that I'm going to want to multiply with a calculator really quick. Let's see, 0.04 times 150. So that's going to be $6 plus, and then we have 0.10 times 90. Well, that's going to be $9. And I know together we have to spend no more than $15. And so it works in the second one as well. So I've just proven that this is actually a solution. So remember, our solution is an XY ordered pair that works in both. And that's what we've shown here, right? It's an XY 150, 90 works in the second equation. 150, 90 works in the first equation. It's that point of intersection on our graphs. That's going to be the solution to our system. So our constraints were that we wanted to spend exactly $15 and we needed 240 yards. As always, make sure you're asking for help in class when you need it.